Black holes are among the most mysterious and fascinating objects in the entire universe. They are regions of space where gravity becomes so incredibly powerful that nothing can escape from them, not even light. For decades, scientists have been trying to understand black holes, yet many of their secrets remain unsolved. These cosmic objects challenge everything we know about physics, time, and the nature of reality itself. The deeper scientists study black holes, the more questions appear. Some researchers even believe that black holes could hold clues about the ultimate fate of the universe. But what exactly are black holes, and why are they so mysterious? To understand black holes, we first need to understand how they are formed. Most black holes are created when massive stars reach the end of their life cycles. Stars produce energy through nuclear fusion, a process that converts hydrogen into helium and releases enormous amounts of energy. This energy creates an outward pressure that balances the star's gravity. However, when a massive star runs out of nuclear fuel, this balance disappears. Gravity suddenly becomes the dominant force, causing the star to collapse inward at incredible speeds. In some cases, this collapse leads to a powerful explosion known as a supernova. What remains after the explosion is the star's core. If this core is massive enough, it continues collapsing until it becomes infinitely dense. At this point, a black hole is born. The boundary surrounding a black hole is called the event horizon. This is the point of no return. Once anything crosses the event horizon, it cannot escape the black hole's gravitational pull. Even light cannot escape from beyond this boundary. That is why black holes appear completely dark. Scientists cannot see them directly. Instead, they detect black holes by observing how they affect nearby stars, gas, and light. One of the strangest features of black holes is their effect on time. According to Einstein's theory of general relativity, gravity can bend both space and time. Near a black hole, this effect becomes extremely powerful. If a person were able to approach a black hole safely, time would begin to slow down compared to someone far away. From the perspective of an outside observer, the person near the black hole would appear to move slower and slower. In fact, if someone were falling into a black hole, an outside observer might see them freeze in time near the event horizon. The person falling in would appear to slow down and fade away, never fully crossing the boundary. However, from the perspective of the person falling into the black hole, time would seem completely normal. Another strange phenomenon associated with black holes is called spaghettification. This occurs because gravity near a black hole becomes incredibly uneven. The gravitational pull on one side of your body would be much stronger than on the other. As a result, any object approaching a black hole would be stretched into a long, thin shape, similar to a strand of spaghetti. This extreme stretching would eventually tear objects apart at the atomic level. Despite their terrifying nature, black holes are surprisingly common in the universe. Scientists estimate that there may be millions of black holes in our own galaxy alone. At the center of the Milky Way galaxy lies a supermassive black hole known as Sagittarius A star. This enormous object has a mass about 4 million times greater than our Sun. Supermassive black holes are found at the centers of most galaxies. Some of them contain billions of times the mass of the Sun. However, scientists still do not fully understand how these gigantic black holes formed. Some theories suggest they grew slowly over billions of years by consuming stars and gas. Others propose that they formed rapidly in the early universe. One of the biggest mysteries about black holes is what happens inside them. According to current physics, the center of a black hole contains something called a singularity. A singularity is a point where density becomes infinite and the laws of physics break down completely. At this point, our current understanding of space, time, and gravity no longer works. This is one of the reasons black holes are so important to scientists. They may hold the key to unifying two major theories of physics: general relativity and quantum mechanics. General relativity explains gravity and the behavior of large objects like planets and galaxies. Quantum mechanics, on the other hand, describes the behavior of extremely small particles. Both theories work extremely well in their own areas, but they cannot fully explain what happens inside a black hole. Another fascinating mystery is the so-called black hole information paradox. According to quantum physics, information can never be destroyed. However, when something falls into a black hole, it seems to disappear completely. This creates a contradiction between the laws of quantum mechanics and the predictions of general relativity. Physicist Stephen Hawking spent many years studying this problem. In 1974, he made a groundbreaking discovery. Hawking predicted that black holes are not completely black. Instead, they slowly emit radiation, now known as Hawking radiation. The more scientists study black holes, the more mysterious they become. They challenge our understanding of the universe and push the limits of modern science. And despite decades of research, many of their secrets remain hidden in the darkness beyond the event horizon.